What if I told you that inside every volcano on Earth holds enough power to run entire countries? Think about it. Those mountains of fire that once buried cities, destroyed civilizations, and changed the climate of the planet might also hold the key to unlimited, clean energy for the future. It sounds crazy, right? Because when we hear the word volcano, we imagine chaos, eruptions, lava, smoke, and destruction. But what if, instead of running away from volcanoes, we could actually plug into them? Could humanity one day power our lights, our cars, and even entire megacities directly from the Earth's fiery heart? Let's find out. A single volcanic eruption can release more energy than the most powerful nuclear bombs ever created. For example, when Mount St. Helens erupted in 1980, it released 24 megatons of energy. That's over 1,600 times more powerful than the atomic bomb dropped on Hiroshima. And here's the crazy part. That energy doesn't just appear during eruptions. It's always there, quietly stored under the ground in the form of superheated rock, steam, and molten magma. Scientists estimate that the heat trapped under Earth's crust could power human civilization thousands of times over. In other words, we're sitting on a giant battery, and we barely use it. Now, you might be thinking, don't we already use geothermal energy? And yes, we do. Places like Iceland, Kenya, and New Zealand already run large parts of their electricity grids on geothermal plants. They pump hot water and steam from deep underground, which spins turbines and creates electricity. But here's the problem. This method only scratches the surface. We're tapping into warm pockets, not the true furnace of the Earth. The real treasure lies much deeper, where magma itself bubbles, hotter than anything we can currently handle. That's where volcanic energy comes in. So imagine this. Giant pipes drilled into the side of a volcano. Water is pumped in, instantly heated to extreme temperatures, and comes back up as supercritical steam. Now, what is supercritical steam? It's not ordinary steam. It's a special state of water where it carries 5 to 10 times more energy, enough to make a single volcanic power plant generate electricity for millions of homes. If this technology succeeds, a single volcano could replace dozens of coal plants or even nuclear stations. And unlike solar or wind, which depend on weather, volcanoes never stop. Their heat is constant day and night for millions of years. So how exactly could we do this? Scientists are working on a few radical ideas. 1. Enhanced geothermal systems, or EGS. Drill several kilometers down, fracture hot rock, and pump water into it. The rock heats the water, which comes back up as steam. This is already being tested in the US and Europe. 2. Closed-loop systems. Imagine sealed underground pipes that never touch the rock directly. Water inside them circulates, heats up near magma, and comes back up safely. It's like charging a battery without ever touching the dangerous parts. 3. Direct heat conversion. Some experiments explore skipping turbines completely. Instead, they try to directly convert volcanic heat into electricity using advanced materials. It sounds like science fiction, but so did nuclear power once. Here's where the story gets intense. Drilling near a volcano is like poking a sleeping dragon. If you get it wrong, the consequences could be deadly. Could drilling trigger an eruption? Most scientists say probably not. Volcanoes erupt because of pressure from deep within, not because of surface drilling. But the risk is still there. And even if you don't trigger an eruption, building power plants near active volcanoes means living next to danger every day. Then there's the engineering challenge. No machine today is built to withstand temperatures over 1,000 degrees Celsius or 1,800 degrees Fahrenheit, and pressures hundreds of times greater than the surface. The materials would melt, warp, or shatter. So before we even get close to plugging into a volcano, scientists have to invent stronger drills, smarter sensors, and new heat-resistant alloys. Now, why take such a big risk? Because the rewards are enormous. Infinite energy, volcanoes could give us
non-stop electricity. Unlike solar and wind, which only work in good weather. No fossil fuels. That means no coal, no oil, no massive CO2 emissions heating the planet. Cheap power. Once the plants are built, volcanic energy would cost almost nothing to maintain. Energy independence. Countries sitting on volcano belts, like Indonesia, the Philippines, Japan, and parts of Africa, could power themselves without ever importing oil again. Imagine Africa lighting up with affordable, renewable energy. Imagine entire megacities in Asia powered by volcanoes. This could change the balance of global power forever. So, if volcanoes are so powerful, why hasn't anyone built a volcano power plant yet? The answer is simple. It's insanely difficult and expensive. The drilling technology barely exists. The cost of a single deep volcanic well could be in the billions. And no politician wants to take the blame if an experiment goes wrong and a volcano erupts. But history shows that today's impossible ideas can become tomorrow's reality. Think about airplanes. People once laughed at the idea of humans flying. Or nuclear energy, once unthinkable, now powering millions of homes. The same might one day be true for volcano power. Picture the year 2100. Cities on the Pacific Ring of Fire, Tokyo, Jakarta, Manila, glow at night with power drawn straight from the volcanoes around them. Instead of coal smoke, we see clean skies. Instead of oil wars, countries fight to develop the best geothermal technology. And maybe, just maybe, volcanoes, once seen only as symbols of death and destruction, will become monuments of survival, proof that humanity can take even the planet's most dangerous forces and turn them into hope. So what do you think? Should we risk drilling into volcanoes to unlock this ultimate source of energy? Or are some forces of nature simply too dangerous to control? Tell me in the comments below. And if you enjoyed this volcanic journey, make sure to hit like, share this video, and subscribe for more mind-blowing explorations of science and mystery. Because sometimes the answers to our future are buried deep in the fire beneath our feet.